Welcome to qnawire.
And so we are asked which of the pairs has a lower charge to volume ratio. And here charge, we care about the magnitude, we don't care about whether it's positive or negative. So A, we have a bromide ion or an iodine ion. And so both of those are in group 7 and both of them have a -1 charge, right? However, because bromine is above iodine in the periodic table, it means it has less volume. And this means iodine has the lower charge to volume ratio, because the higher the volume, the lower the charge to volume ratio. In the next part, I compare between Sc, which has a 3+ charge, and Ca, which has a 2+ charge. So both of these have, if you look at the periodic table, they're in the 4th row, which means they both have 4 shells. However, calcium is on the left of cesium, which means that cesium has, or Sc has, greater number of protons, and so it has a greater pull on the valence electrons. And so it is slightly, just very slightly, smaller in volume. However, they're almost the same in volume, but here I have a charge of +2. Meanwhile, here I have a charge of +3. In this case, the difference in the ion charge dominates over the slight difference in volume. And so Ca2+ has the lower charge to volume ratio. In the next part, I'm asked to compare between a bromide ion and a potassium ion. So both of them have a magnitude of +1 charge, and both of them actually lie in the 4th row, and so they both have 4 shells. However, bromide has more protons, and so it exerts greater pull on the valence electrons, and so it has smaller size or a smaller volume. And so K+ has the K+ has greater charge to volume ratio, and this means that a bromide ion has the lower ratio of charge to volume because it has a lower volume. For part D, I have a chloride ion and a sulfur ion. So if we look at the periodic table, they're both in the 3rd row, and so they both have 3 shells. A chloride ion has more protons, and so the protons exert a greater pull on the valence electrons, and so it has slightly lower volume. However, the main part here, since the difference in volume isn't significant, they both have 3 shells, is the charge. Here I have a greater charge magnitude, and so basically a chloride ion would have a lower charge to volume ratio. All right, here I'm comparing between these two, and they both have the same charge. However, if I look at the periodic table, aluminum is on the right of, aluminum is above Sc, so this has 3 shells, this has 4 shells. This means it has a larger volume and hence a lower charge to volume ratio. And so this is our winner. And so here I have 2 compound ions, and SO4 2 minus. They have around the same size, so the dominating factor is the charge. This has a greater charge, and so this has a lower charge to volume ratio. All right, two more. Here for G, I have Fe3 plus or Fe2 plus. These have the same number of shells and they have the same number of protons in the nucleus, so they exert the same influence on the valence electrons. This has less electrons, so it has slightly lower electron-electron repulsion. However, that's a very, very, very minor component compared to the difference in charge. This has a lower charge, and so the dominating factor is the charge, and so this has a lower charge to volume ratio. The last one is Ca2 plus or K plus. As we can see, both of them are in the fourth row of the periodic table, and so both of them have 4 shells. Now, Ca2 plus has a slightly smaller size, and K plus is lower in charge and greater in size, and so the winning or dominating and lower charge to volume ratio is K plus.